Let us look at superposition principle. Supposing we have more than two charges, that is, we have a number of charges, and we want to find the force on a charge or how the forces between multiple charges are acting. Let us say this is a charge Q and there are a number of charges Q1, Q2, Q3, let's say Qn, and the distances between them are R1, R2, R3 and Rn. Then the forces acting on charge Q due to the various charges could be F1, F2, etc. Now if we want to find out net force on charge Q, it will be the vector sum of all the charges. Vector sum means that we have to take the magnitude as well as direction into account. To understand the law of superposition or superposition principle, let us look at a numerical problem. Let us say three identical charges Q are at three positions A, B and C. This is position A, so charge Q is lying here. This is position B and charge Q is lying here, and this is position C, charge Q is lying here. Since the distance between A and B is, let us say, 0.015 meters, and the distance between B and C is 0.010 meter. Now since the charges are identical, the force on B due to A will be a force of repulsion. So this is indicating the direction of force on B due to A or FBA. Now when we are looking at the direction of force, it is important to remember that we will consider only the charge on which the force is being calculated. So in this case, the force is being calculated on the charge at position B. So the force due to charge on A on charge at B will be in the direction shown. Now if we calculate FBA, now let's say it's given in the question that FBA is already given is equal to 2 into 10 raised to minus 6 Newton, and we have to find the net force on B. That is, we have to find FB. So this implies that we don't know the charges, we have to find the force on B due to the charge at C, and then we have to add them vectorially to find the net force. So FBA in magnitude can be written as K Q square upon 0.015 square. This is from the Coulomb's law, where Coulomb's law says that F is equal to K Q1 Q2 by R square, and K is equal to 9 into 10 raised to 9 Newton meter square per Coulomb square. So from here we can say that 2 into 10 raised to minus 6, which is the given data, is equal to K Q square upon 0.015 whole square, or Q square can be written as 2 into 10 raised to minus 6 into 0.015 whole square divided by K. Now we write the equation for force on B due to the charge at C. So FBC is what we have to find out. So we can say that direction of FBC will be as shown. Alright, that is, it's again a force of repulsion and it will be pointing away from C. So FBC can be again written as KQ square, and the distance between the charges at B and C is 0.010 whole square. Now we substitute for Q square from the equation above, and we get K upon 0.010 whole square into 2 into 10 is power minus 6 into 0.015 whole square divided by K. K and K cancel, and this is equal to 2 into 10 is power minus 6 into 15.015 divided by 0.010 whole square, which will turn out to be equal to 4.5 into 10 is power minus 6 Newton. So the two forces acting are like this, FBC and FBA. And if we have to find the net force, in this case these two forces are perpendicular to each other, then this diagonal will indicate the force FB. So using the laws of vector, we can see that FB will be equal to under root of FBA whole square plus FBC whole square, which is equal to under root of FBA is it's given to be 2 into 10 is power minus 6 whole square plus 4.5 into 10 is power minus 6 whole square, which turns out to be equal to 4.92 into 10 is power minus 6 Newton. If you also want to indicate the angle theta, so theta is the angle with respect to the force FBA. So we can say FBA is acting along the x-axis and FBC is acting along the y-axis. Then we can say that theta is equal to tan inverse of FBC upon FBA, which turns out to be equal to tan inverse of 4.5 divided by 2. So this way we will find, using the laws of vector, both the direction and magnitude of the force on B due to two charges, the charge at A and charge at C.